messieurs, au nom de l'Association des Climato-réalistes, je vous souhaite à tous la bienvenue dans ce bel hôtel de
On behalf of the Association des Climato-réalistes, I wish you a welcome in this beautiful Hôtel de l'Industrie for this exceptional evening together with E Koonin. Before introducing him and giving him the floor, I cannot fail to congratulate myself on the fact that France once more has saved the world. The last time was in 2006 when the fear of the avian flu was at its peak. The press was broadcasting disturbing pictures of this or that dead bird in Poland or Austria. The end of the world was near. Everyone was trembling. Fortunately, President Jacques Chirac and his Prime Minister, Dominique de Villepin, had reacted by proposing the creation of a new type of employment contract, the contrat première embauche, first employment contract, with the result that immediately hundreds of thousands of demonstrators took to the streets and had driven the dead Polish birds off the front pages of the press forever. And that was the end of the bird flu. Today, the apocalypse is climatic, with the publication on Monday of the 6th IPCC synthesis report. And so the French executive has acted with a pension reform that has turned throngs of hundreds of thousands of demonstrators into the streets again with an excellent result. And nobody's talking about the IPCC's concerns. So we are saved, and let's be proud to be French. E Koonin is American. He's a physicist at New York University. Has worked on nuclear physics as well as environmental sciences and computational physics. He's the author of more than 200 scientific articles and has been a member of the AAS since 2010. So he's a leading scientist of the world. It's an honor for us to have him. His skills have earned him the appointment as Under-Secretary of Energy for Science and Innovation in the administration of President Barack Obama. And his biography is on the website of the American Academy of Sciences, presents him as a strong supporter of research in renewable energy and alternative energy sources. In 2014, he started taking part in the climate debate explicitly in a text that was published by the Wall Street Journal entitled "The Climate Science is Not Settled." Climate Science is not settled. That was the title. And 7 years and many other contributions later, he publishes Unsettled, which became a bestseller in the US with 200,000 copies sold. His translation in French, Climat, la part d'incertitude, is equally successful in France. A clear book, yet scientific. It is moderate in tone, as E Koonin is an example of moderation and precision, which means that the only criticism you can really level at him is going to be and is ad hominem. E Koonin wins in every contradictory debate. The last time was recently at Cornell in the state of New York, where the 47% of the audience that were in favor of him at the beginning ended up being 68%. And opposite results for the other side. His French tour, organized by the irreplaceable Marie-France, has been a resounding success. We can maybe give her a round of applause. He has already been interviewed by many national media. Yesterday, for example, Sud Radio, which is an interview that's already been viewed more than 25,000 times on YouTube. You can find it there, of course. Climate realism has suffered from the fact that it's only been able to establish itself as a bastion of resistance, valiant but isolated, and until now, pretty much unable to move the conversation. But with E Koonin, this ability
pour contribuer à donner à cet événement tout l'éclat qu'il mérite. Cher Stephen, la parole est à vous.
Thanks to the association for making it possible for me to help spread the message here in France. Thanks to Marie-France, of course, for all the hard work in arranging this, and all of the rest of you who've come out tonight under somewhat difficult circumstances to talk about this very important subject. My title I've chosen really has a triple meaning. Unsettled refers to the state of the science itself. It also refers perhaps to how you might feel, and indeed how I felt when I started to realize some of the things I'm going to tell you tonight. And it also refers to the fact that what we're going to do about the circumstances we find ourselves in is also an unsettled matter. If I were to paraphrase the current consensus discussion from the scientists, from the politicians, from the media, it is that the science compels us to make large and rapid reductions in greenhouse gas emissions. What do we mean by that? Well, here, for example, from a recent UN report, is the history of global greenhouse gas emissions from 1970 until last year. And you can see that it goes up monotonically, and that most of it is carbon dioxide, but there is some associated with methane and other minor gases. What large and rapid means, according to the UN, is that we have to drive this curve on the left to zero by 2050 if we want to allegedly keep the global temperature rise below 1.5 degrees, to use the phrase that is commonly quoted, avoid dangerous human influences on the climate. And so this curve, which is schematically illustrated here, has to go down all the way to there by 2050. Whatever we do about this has to strike a balance. On the one side, we've got the certainties and uncertainties of the climate science. We've got the hazards and risks of a climate changing for whatever reason, whether natural or human-caused. On the other side, we have the world's growing demand for reliable, affordable, and clean energy. And as we strike that balance, we need to invoke society's values, priorities, tolerance for risk, equities between generations and between the North and the South of the globe, and of course to consider the efficacies and costs of various responses. And I would assert that we need to think about, if we're going to attempt to drive that curve to zero, are these large and rapid reductions warranted? Are they desirable? And are they possible? And I'd like to turn to each one of those questions as I go through the next many minutes. So let's talk about warranted first. Here is the global temperature record. It's actually the anomaly in the temperature from 1850 up until more or less the present. And what we see is that the globe has warmed about 1.3 degrees since 1900. I'm going to take that as a baseline. Comparable warming, if you read the IPCC reports, and by the way, almost everything I'm going to tell you tonight is right out of the IPCC reports, or the data, or the underlying research papers. So whatever I'm telling you is not Steve's science, but in fact is the IPCC science. So comparable warming, another 1.3 degrees, is projected over the next century. And the real question is, what will be the impacts of that warming? Well, that's a pretty difficult thing to do, but one of the things we can do is look back and ask what's happened over the last 120 years. And what you discover when you look at various metrics is that humanity has prospered despite, or perhaps because of, the 1.3 degree warming since 1900. The population of the globe is 5 times larger than it was in 1900. We're now at about 8 billion people. Life expectancy went from 32 years to almost 73 years, globally averaged. The fraction of people who are literate went up by a factor of 4. The GDP per capita grew by almost 7 times in constant dollars. And maybe most importantly, for people who believe that a catastrophe is imminent with the climate, the weather death rate, the death rate from extreme weather events, dropped by a factor of 50. It's difficult to believe when you look at all of this that another warming of 1.3 degrees is going to significantly derail or even reverse this kind of progress. Well, you might say that was an average over the last 100 and something years. Human influences have only been operative for the last 30 years, and at least according to the media, we have broken the climate, and we're already seeing terrible impacts. Well, I like to look at the data. This is some data that Roger Pilkey Jr. likes to put together. This is global weather losses as a percent of global GDP. The data are from Munich Re and the World Bank. It's over the last 30 years. And what you can see is that there are variations from year to year, as you would expect, but the scale is measured in tenths of a percent of global GDP. And if anything, the trend is downward, although I wouldn't put too much stock in the trend. If you look at other studies I have here in the box, global average mortality and economic loss rates have dropped by factors of several from 1980 up until the recent decade. All right. So, if anything, the world is not suffering from greater climate catastrophe over the last 30 years. In fact, that's not surprising, because if you look at the most recent IPCC report about the climate itself, not the impacts or not mitigation strategies, what you find is that it's tough to detect or attribute trends in most extreme weather. So just to quote some things, obviously I'm not going to go through these all, there's low confidence in most reported long-term trends in hurricanes, tropical cyclones. There's low confidence in extratropical mid-latitude storms. There's no evidence for a trend in tornadoes, hail, lightning. The one where I think you can say there has been something is that the frequency and intensity of heavy precipitation has likely increased at the global scale over most of the land with good coverage. That doesn't mean there are more floods, because in fact, floods are a lot more than just how much it rains, but nevertheless, it's hard to see a trend in most extreme weather events. What people don't realize, most people, and the media exploit shamelessly, is that climate is not weather. Climate is the statistical properties of weather over decades, officially 3 decades, 30 years. And because there are long-term trends in the climate, you can get fooled. I like to use an example from Egypt. If you go to Cairo, there is an island in the center of Cairo, Rhoda Island, shown here on the map. And on the southern tip of that island is a structure that was built many thousands of years ago, actually. This is the modern structure that is meant to measure the height of the Nile. This is what it looks like today. If you were to go inside, there is a large vertical chamber with 3 openings at various levels of the river. There is a beam with Arabic inscription across the top, and suspended from the beam is a pillar marked in cubits. And the Egyptians, of course, had great importance for the level of the Nile, not only the Egyptians, but the people who taxed the Egyptians over the years. And so they built this structure, and we have a wonderful record of the height of the Nile year by year. This is a pretty good measure of the climate of about 10% of Africa, which is about 1/3 of the continental US and area. So it's not a local thing at all. And what you see when you look at this record, which extends from the middle of the 7th century up until the middle of the 15th century, is that if you look at the annual values, there's a great variation up and down. One year it can be as high as 6 meters. This is the annual minimum, by the way. And another year it can be down below a meter or so. You might say, okay, climate is the 30-year average, and so you construct the 30-year running average, which is the red curve, and what you can see is that even that has a long-term, multi-decade, century scale structure. This is not unknown to hydrologists, but you could just imagine that there was some medieval climate panel urging more prayers and sacrifices and screaming, new normal, new normal. And of course, if they had just waited a century or so, it came back up again. This is entirely natural variability, obviously. Nevertheless, you can get fooled. We continue to do the same thing today. In 2006, NASA issued a press release, Lake Victoria's falling waters. Lake Victoria is important because it is a major determinant of the height of the Nile at the minimum. And then in 2021, Lake Victoria's rising waters. So this graph should give us a little bit of humility as we attempt to project regional climates, at least. The media exploit this shamelessly. Here's another example. I published in the Wall Street Journal in February of last year, just about a year ago, a piece about Greenland's melting ice. NASA issued a press release in March 2020. Here is the Guardian article in December of 19. It says, Greenland's ice sheet is melting 7 times faster than in the 1990s. And they say in the text, the rate of ice loss has risen from 33 billion tons a year in the 90s to 254 billion tons a year in the past decade. Wow, big numbers going up real fast. And if you didn't know anything, you would say, oh my God. Well, I had the temerity to publish the official data on the melt rate in the Wall Street Journal, and that's what it looks like. This is from the Danish Meteorological Institute. The reference is there, Mankoff et al. And sure enough, in fact, from 1990 to 2015 or whatever, it went up a lot. Somebody's ringing, right? Okay. It always happens. But what they didn't tell you is that it was almost just as high in 1930s, and it went up just as rapidly. And in fact, since the article was written, there are, of course, annual values coming in, and it's going down again. Right. Given that human influences were increasing steadily during this time and were only 1/5 as large in the 1930s as they are currently, this has clearly got very little to do with greenhouse gases at all. Probably, we don't know exactly, it's got to do with what's called the Atlantic multi-decadal oscillation, namely variations entirely natural in the North Atlantic in terms of currents and temperatures and winds. So you can fool people by cherry-picking the interval. We see that kind of misrepresentation even today. And I want to give you an example from the most recent IPCC report that was released on Monday. So I want to talk about temperature-related deaths. And you go to the journal again, in this case, The Lancet, an article with 30 or 40 authors, pretty thorough analysis. And what they found is that we found there were 5 million, I don't know why they give 6 significant figures, but anyway, 7, thank you. 5 million deaths per year associated with non-optimal temperatures, accounting for 9.43% of global deaths. This is over some recent multi-decade period, equating to 74 temperature-related excess deaths per 100,000 people. For those of you who don't have death rates in your head. 74 is about the global death rate from infectious diseases before COVID. Most excess deaths were linked to cold temperatures, 8.5 of the 9.4%, whereas fewer were linked to hot temperatures, only 0.9. So that deaths from hot temperatures were about 10 times bigger than the deaths from cold temperatures. And what they found is that the global daily temperature increased by 0.26 degrees per decade over the last 20 years. That paralleled with a large decrease in cold-related deaths and a moderate increase in heat-related deaths. And in fact, if you look at the net, there were actually 0.3% fewer deaths overall because of this warming. And now you go to the most recent IPCC report, which was released on Monday. They have only one sentence about temperature-related deaths, and here's what they said. In all regions, increases in extreme heat events have resulted in human mortality and morbidity with high confidence. This is a statement that's completely factual, but is factually incomplete. And what I read into this, as I have written in the book, the IPCC is there to persuade you, not to inform you. This is terrible for a scientist to write something like this. I would have failed one of my students if they had done that. One more about whether it's justified or not. I want to talk about the economic impact of warming. And if you read the U.S. National Climate Assessment from 2018, they say, in the absence of more significant global mitigation efforts, climate change is projected to impose substantial damages on the U.S. economy that could grow to hundreds of billions of dollars by the end of the century. Again, most people are not very numerate, and hundreds of billions sounds like an enormous number. To back up this statement, the report gives you this table, which shows annual damages to various sectors of the economy under a high emission scenario, which is the gray column, and then how much of the damages you would avoid under a more moderate emissions scenario. And there are a couple of remarkable things about this table when you look at it. First of all is the degree of granularity. They start with the labor sector on the top, and then they go all the way down to shellfish. The second is the fact that the precision. The labor impact is 155 billion, right? Not 150, not 160, but 155. And then finally, they don't give you a baseline. 155 billion compared to what? They don't tell you what the labor sector is of the economy in 2090, even what the labor sector is of the economy today. It's probably about half of the US economy, which is of order $10 trillion. So in fact, just taking their own numbers, this is a nothing burger. We will see that in a second a bit more. Nevertheless, when the report was released, climate change will wallop the US economy. Even Fox News said, climate report warns of grim economic consequences, all right? Well, if you read further in the report, the last figure in the last chapter has got this graph, which shows the percent of economic damage to the US GDP as a function of temperature rise. Sorry, it's in Fahrenheit, but just divide by 2. And what's remarkable is that for changes of a few degrees Celsius, you see that the impact on the GDP in 2090 or 2100 is a few percent. There is a comparable graph from the literature. Bjorn Lomborg put this graph together. The IPCC says the same thing, a few percent for a few degrees. What does that mean? Well, first of all, the IPCC realized that, and it says it. In the 5th assessment report, it said the impact of climate change will be small for most economic sectors relative to the impact of other drivers. There are many other aspects of society, technology, demographics, trade, and so on, that are much more important. And in fact, all of the IPCC scenarios that it uses to project the future include substantial economic growth. So at least according to the IPCC report, never mind the summary for policymakers, there is no climate crisis. So that's what the graphs look like. If you take the US GDP and assume it grows at 2%, you get the blue curve. If you assume a 4% impact on the GDP in 2100 due to the climate, you get the orange curve, and even a 10% impact in 2090, you get the gray curve. So what you see is that there is a climate-induced delay of a few years in the growth. Of course, these are small impacts, and one should realize what the uncertainty is in projecting the GDP itself. Anyway, I would love to have on the stage Mark Carney, John Kerry, anybody who's advocating rapid reductions, and ask, is this what you mean by the climate crisis? So that's about the justification for large and rapid reductions. Let me ask whether large and rapid reductions are even desirable. And to do that, I want to look at some global trends. This is the global population, historically and as projected to 2050. You can see that we are just crossing 8 billion people right now. We're expected to go to 9 billion people, plus or minus, by the middle of the century, and you can see most of that growth is in Asia. What is perhaps not so obvious if you haven't thought about it is that energy is essential for development. This shows, for various countries listed on the right, the annual energy use per capita in gigajoules, plotted against the annual GDP per capita in thousands of 2017 dollars. 1 point on the trajectories for each year. And what you can see is that there are some countries, including the US, whose energy use per capita is pretty high compared to the others, and the GDP per capita is slightly greater than many of the others. There's a broad group of countries in the middle, including many of the EU countries and France, yes, whose energy use per capita is about half that of the US, and whose GDP per capita is slightly lower. And then there is another group of countries down in the lower left of this chart, whose energy use per capita increases universally and monotonically, steadily, as they become richer. And what is most sobering about this chart is that there are about 1.5 billion people of us in the developed world, in the upper right, whereas there are 6.5 billion people in the lower left who are going to use more energy as they become better off. The inequalities in that chart are outstanding and really surprising. This is one image of energy poverty, people using wood and dung for cooking and heating inside. The indoor air pollution is terrible. It kills about 2 million people a year. And as I've said before in other contexts, dining by candlelight is very romantic, but studying by candlelight is not something that you would wish for. Quantitatively, the US uses 30 times the energy per capita that Nigeria does. My guess is France is about 15 times as much. And there are 3 billion people in the world who use less electricity per year than the average US refrigerator. This is terrible. When you combine the demographics with the development, energy consumption is expected to grow by 50% in the next 30 years. Most of that growth will, of course, be in Asia. And if you assume no changes in policies, most of that growth will be satisfied by fossil fuels. Renewables will grow, as shown in this chart from the US government, but in fact, the fossil fuels will grow even more. In fact, fossil fuels currently supply about 80% of the world's energy, which is a number that has remained the same over the last 30 years. Some people are trying very hard to reduce fossil fuel consumption. The world has spent about $4 trillion over the recent decade to try to bring down that top curve. Not much impact so far. That growth in energy consumption by the developing world is going to drive increased emissions. This is an EIA chart, the US Energy Information Agency. It shows emissions, carbon dioxide, historically from 2010 to 2020, and then projections going forward. And you can see for the OECD countries in the developed world, emissions will decline slightly, expected to, whereas emissions from the rest of the world, the developing world, will grow. I've become a fan of an American economist, political scientist named Anthony Downs. He died a year or two ago, and in the 1960s was working at UCLA in Los Angeles. And during the 1960s, he was watching the smog get worse and worse as more and more people were able to afford automobiles. And he wrote a wonderful paper called Up and Down with Ecology in 1972. And he said in that paper, the elite's environmental deterioration is often the common man's improved standard of living. Think about that with respect to the situation I just described for you for energy and development. And so when we, some of us in the US, say that science compels us to make large and rapid reductions, the response from the developing world is, what do you mean us? And in fact, they say that explicitly. There is the Indian Prime Minister a little more than a year ago saying the colonial mindset hasn't gone. We're seeing from the developed nations that the path that made them developed is being closed for developing nations. And the Nigerian president, about 8 months ago, said Africa is being punished by the decisions of Western countries to end financing for foreign fossil fuels projects by the end of 2022. We, the Africans, are going to continue to fight. We have fossil fuels that should be exploited. And many of you may be reading recently about a pipeline in Uganda that the World Bank has refused to fund. My guess is that the Chinese will go in and fund that anyway. So there is a moral question here about restraining the development of the developing world because, in fact, fossil fuels are the most convenient and reliable way for them to get the energy. As we will see in a bit, wind and solar are just not going to cut it. There's another moral dimension here. By exaggerating the climate threat, we have depressed young people and robbed them of their optimism. Here's an example of a demonstration in the UK, and even celebrity influencers, right? Here's Miley Cyrus saying a little while ago, we're getting handed a piece of shit planet, and I'm not going to bring another person into the world to deal with that. This is terrible, right? And it's even scarier because most of this climate fear is in the West. It's not in Asia, who have more important and immediate problems to be dealing with, okay? So there is a moral dimension, and I would assert it's not even desirable right now to reduce emissions because these folks in the developing world need energy. I always also wanted to put a picture of Miley Cyrus in one of my talks. So do that. And then let's say, okay, maybe that's the developing world. What about those of us in relatively rich countries? Can we do it? are large and rapid reductions possible? The first thing one has to realize is that energy systems naturally change over decades. This is where the US got its energy over the last 70 years. We started with wood, coal, a little bit of oil. Natural gas became more and more important, the brown segment, and the renewables, wind and solar, biofuels, so on, have come in at the very end. And what is instructive about this graph, several things. One is it takes decades to change things. It takes decades because energy facilities last a long time, 50 years for a power plant at least. Automobiles last for 20 years or so. The energy system has to be highly reliable, and so you don't want to change it very rapidly. And even when you introduce new energy sources, the old ones don't disappear. You just pile on the new source on top of the old. The one exception is in the last decade or so, you can see the gray region is going down. Coal is disappearing in the US, not so much for emission reasons, although that's part of it, but more importantly and more significantly, the US has been producing lots and lots of natural gas. And people are substituting the gas for the coal. As the world hurdles to try to make everything all electric and reduce emissions, this is the image that I like very much. Wile E. Coyote, I gather, is familiar to people in France. And in this particular cartoon, he's suddenly realized that there are some fundamental circumstances that are going to mean that things don't go very well for him in the future. So what are some of those fundamental things? A lot of it's got to do with the electrical grid, though not all of it. The strategy is to replace petrol and diesel in vehicles with electricity, and to replace heating in buildings with electricity, and then to green the grid, reduce emissions from the grid. So the grid is central to decarbonization strategies. We would like the grid to be clean, low emissions. We would like the electricity it produces to be affordable, and we would like the electrical grid to be reliable. And of these three things in the triangle, if you want to have an affordable and reliable grid, coal and gas, modulo import issues, work just fine. If you want it to be affordable and clean, wind and solar work okay, but reliability is an issue, as we will see. And if you want it to be clean and reliable, but not particularly affordable, fission, storage, carbon capture and storage are technologies to look at. The current push, even in France, to my surprise, is to deploy wind and solar. And if you were to do that, as I'll show you in a second, the most expensive part of an all renewables grid or a high renewables grid is not the generation, but it's the reliability. We do not have right now the technologies to satisfy all three of these criteria. So let me talk about reliability for a second. I go back to data again. This is 6 months of daily wind generation data in the UK at the end of 2020 and the end of 2021. And what you can see is that there are long periods, as long as 11 days, in which the wind is not producing at all. There are similarly long periods where the solar is also gone and the wind is not producing. The Germans have a name for it, Dunkelflaute. And that means that you have to have a backup system to turn on when the wind is not blowing. These Dunkelflauten happen all over the world. Texas has often 2 months where the wind is not producing. And so this backup system has to be at least as capable as the wind and solar. And since wind and solar are in fact the cheapest ways of generating electricity, but not very reliable, the whole electrical grid is going to cost at least twice as much as what you thought it would with wind and solar. And then by the time you've made a very capable backup system, you might be asking yourself, why are we even using wind and solar at all? And that's a good question. Here's a study that was done by my former colleague and still good friend Nate Lewis at Caltech, Ken Caldera at Stanford, and Jackie Dowling, where they looked at real weather statistics, not statistics, the real weather data, over the entire US at a county-by-county level, hour by hour, for I think 30 years. And they asked if I were to optimally deploy wind and solar and make it a criterion that I had to satisfy the load 99.99% of the time, which is the US standard, what would the cost be of various technologies? And what you can see on the left is that natural gas with carbon capture and storage, or natural gas plus wind and solar would be pretty cheap. But as you go to the right, solar only plus batteries, wind only plus batteries, or wind and solar plus batteries, you can see that the costs go up by at least a factor of 2. Right? This also does not account for transmission costs and other costs, but assumes a reasonable technology cost. So a reliable, renewable grid is going to be very expensive. There are other drawbacks to renewables. Renewable energy is land intensive. This is a US government chart, and it shows how much land each of the technologies use to produce electricity. And you can see wind uses about 8 to 10 times as much land as coal, geothermal, and nuclear. It's because wind is a diffuse energy source. The modern energy technologies also use much more high-value materials. This is IEA chart. So again, I don't make any of this stuff up. And what you see is that for transportation on the top 2 bars, kilograms per vehicle, you can ask how much copper, lithium, nickel, manganese, rare earths these vehicles use. And you can see that an electric car uses 7 times more high-value stuff than a conventional car does. If we look at the power sector in the lower bars, onshore wind uses about 9 times as much of this fancy stuff as does natural gas. And it's a real question of where is this material going to come from if we're going to deploy these technologies at scale rapidly. Currently, they come from rather inconvenient places. If you look on the left, again, this is an IEA chart. China produces 60% of the world's rare earths. Most of the world's cobalt comes from the Democratic Republic of the Congo. And if you ask where these materials are processed, just looking at the right-hand chart, uncomfortably you see a lot of red bars which correspond to China. So the world does not have the capability now to produce these materials at the scale envisioned, and even what we do now comes from places that we might feel uncomfortable with. I'm going to skip over this chart well, maybe I have some time. A real quick tour of what's going to happen by 2050. Benoit, we're okay with the time? Another 10 minutes or so? That's good? Yeah, okay, good. So it's kind of hard to project out 30 years. The challenge in doing these projections is to be specific enough so that it's got some value, but not so specific as to be almost certainly wrong. And so I'm going to try to do that with some projections. Coal is going to rise, I would say, at least for the next decade or two. We're seeing that already. Global coal production consumption in India is up 8% this year. China is similarly booming. Natural gas will eventually take over. What's not to like? It's clean, it's abundant, it's got lower, but not zero, greenhouse gas emissions. It's domestic for some people who choose to produce it In the US, we've got an enormous amount of it, and we're going to see the continued growth of liquid natural gas as people move the gas around from one producing country to the consuming countries. In France, my understanding is there's a fair bit of gas under the ground here in France, but for various reasons, which you probably understand much better than I, France, and indeed most of Europe, has chosen not to extract that gas by fracking. Hydrogen, I think it's unlikely for transport. This is the current darling. When I was in BP 18, 19 years ago, biofuels were the darling. I think for transportation it's unlikely. Too many downsides which we can go into. But I think as a way of firming power on the grid, so producing hydrogen when you don't have a demand for electricity, but then using it when the demand is high, I think there's a possibility there. It's a question of cost again. I think we will see the electrification of many things. It's already underway for light-duty vehicles, for cars and small trucks. I worry that there are drawbacks which are starting to become evident to people. Grid capabilities, electrical demand is going to go up by 30–40%. The charging infrastructure, I was interested to see charging stations as I walked around this afternoon on the streets. Critical materials, I've already mentioned. Heat pumps in temperate climates, my guess is it'll work in France pretty well, but as you get to more extreme climates, upper Midwest, Scandinavia, and so on, the heat pumps are just not going to cut it. I think wind and solar are going to grow, but they're not going to get to certainly no more than 80% because of reliability issues. Fission, France, I think, and more power to you, so to speak. It's great that you have historically focused on fission and now reaffirmed that that's what the future looks like. Fusion, there's a lot to say. I think fusion will work in a technical sense, but economically, I've got a big question mark next to it. The grid is getting better, and that's something that's going to happen no matter what. Historically, the grid has been a one-way flow of electricity, very little flow of information. With smart meters and other technologies, we can make the grid much better in terms of reliability, efficiency, and so on. The distribution infrastructure is something worth talking about on the grid. So in cities, we've got lots of wires under the ground. As I talk to the people who run the electrical system in New York, their greatest fear is that gas and heating oil will disappear from heating the buildings, that they will shift to all electric. That will double the demand on the grid in Manhattan, and they're going to have to tear up all the streets at great expense to bolster the wiring under Manhattan. My guess is that there would be a similar problem here in Paris. And then finally, bolstering the supply chains. I think the world has realized that indiscriminate globalization is not a particular secure way to get what you need. And certainly in the US, we're seeing a pulling back of the supply chains, and I know that's causing friction between the EU and the US as we fight for who's going to be providing those materials or do the manufacturing. Finally, there's going to be new waste streams. If we really electrify transport, there's going to be a waste stream for batteries. How do we manage that? Can we extract the critical materials for reuse? Batteries, turbine blades, solar panels, and spent fuel. When you look at all of this, I think adaptation is what the world will do. We can argue what it should do. There's a much broader palette of what it could do, but adaptation is what the world will do. Adaptation is agnostic. It doesn't matter whether the climate is changing for natural reasons or human reasons. It's proportional. The climate changes a little, we adapt a little. If it changes more, we'll adapt more. It's local, and so it's politically saleable. You don't have to get people to buy into some vague, distant threat that's going to happen 2 generations from now, halfway around the world. And it doesn't require a global consensus. It's also autonomous. It's what society does. We have adapted very well to 1.3 degrees rise over the last 120 years. We will continue to adapt, and it's just what the human species does, and it is effective. Again, the recent 120 years, but also people live from Hudson Bay in Canada all the way down to the equator, and you build the infrastructure and adapt your society to that. So I think that's what the world's going to do. A couple of final charts. You know, one of the reasons I wrote the book is that I didn't want climate science to be Gruberized. And what do I mean by that? Well, there's this guy, Jonathan Gruber, who's still a professor at MIT. He's an economist. And about 8 or 9 years ago, he was one of the principal architects of the Health Care Act in the US. It's called Obamacare. Its official name is Affordable Care Act. And I think it was a good thing in the US that we made health care available to more people. That's fine. But here's what he said at a conference after it was all over. Lack of transparency is a huge political advantage. It was really, really critical to getting the Affordable Care Act passed. At least one key provision was a very clever basic exploitation of the lack of economic understanding of the American voter. You can find the video clip of him saying this at a conference. And, you know, for a scientist, an advisor, an academic to say that is just a disgrace. When we misrepresent the science, as I would assert the IPCC, the media, and the politicians do, in order to persuade people rather than inform them, they take away the right of non-experts and the public to make informed decisions. They distract from more urgent needs, and boy, do we have so many of them. They tarnish scientific input to other important policy matters like pandemics. And they depress young people. And that's really why I wrote the book, okay? To try to better inform people. Again, not what I say, but what's in the reports that they haven't read. All right, I've been telling you everything that's wrong. Let me tell you, in a positive sense, what I think we collectively, various governments, should do going forward. The first thing is to cancel the climate crisis, right? Tell people that there's no urgency here, and there isn't, but acknowledge that this is something we need to be working on, and it will be a challenge to reduce human influences. As part of doing that, I think we need better representations of the science and the energy technologies to non-experts. I have long advocated red team reviews. That's where you take the report before it's issued, you put in a group of knowledgeable experts, and you ask them, what's wrong with this report? The IPCC does not do that, but we're talking about spending trillions of dollars to reduce emissions, and we should have that kind of validation of the drivers to reduce those emissions. And we need to better educate people about both energy and climate. We must not give up on climate science. We need continued observations and understanding of the climate. You know, the observations have to be continuous, they have to be precise. We must not drop the ball on that. We must not constrain the developing world's energy supply. That is a moral issue, and again, I would love to ask the advocates for rapid decarbonization, what do you do about the developing world? I haven't heard a good answer yet. I think we need a greater focus on adaptation. There's no coherent framework for adaptation. We have not good estimates of the cost. And for the developing countries, which will have to adapt the most, we need to promote their development and their resilience, which is going to mean more energy for them. Need to be working on researching emissions light technology, fission. The reactors, as great as they are in France, I think they're too big to be economic. Small reactors The world is moving in that direction. US has got an effort. The UK has got an effort. China is already deploying small reactors. Grid storage, batteries, non-carbon chemical fuels, all great research topics, but are not there yet for large-scale deployment. And finally, because energy touches, to use the movie title, everything, everywhere, all the time, not all at once. You've got to be very careful about how you change the energy system. If you do it too rapidly, you're going to cause great disruption. And so we need a plan that incorporates technology evolution, economics, regulation, behavior. Nobody has put together such a plan. It's all throwing stuff against the wall. Let's do wind, let's do solar. A little bit of thought would be very welcome as to how we decarbonize. All right, thank you very much for your attention, and I'm happy to take comments.